All right, hello, grade 10s. We are chilling with grade 10s today. Grade 10s, grade 10s, grade 10s. We haven't had a lesson for grade 10 in quite a bit, in quite a while. All right, so grade 10, let's go and actually do some expanding. All right, hello to everyone. Good seeing you on the live. It's amazing to see you. It's been a while. So we are chilling with the grade 10s. Grade 10s indeed, because we haven't had a chance to actually do a grade 10 lesson in a while. And the last thing we did was products, right? Remember, we did products. And when we did products, we basically said that we need to make sure that in products we are dealing with BODMAS if you want. Okay. Nom, please go and make sure that you are following my other channel for grade 8 and 9. So grade 9 and 8, okay, I tend to do in the morning. So for instance, this morning I had a live lesson with the grade 8s. It was on BODMAS. All right, so please just make sure you go and follow my other TikTok channel. It's also called Maths is a Game 527. It has the green profile icon, not the white one. The white profile icon is for grade 10s to 12, and then the green profile icon is for grade 9. So today we are doing grade 10, okay, because we haven't had a chance to do grade 10 in a while. And I'm sure my followers in grade 10 are like thinking, it's also here on TikTok. No, just find it, okay. I'm just gonna try and show you here what it looks like. Just a sec. Let me just try and show you what it looks like. This is what it looks like here. Okay, Maths is a Game 527. So if you click on it, okay, this is the page I'm talking about. It's for grade 8 and 9 only. So please go to my other Maths is a Game. It's 527 BA2. It's got the green profile background. You just go on TikTok there. And please, you go on there, please follow me on that TikTok platform as well, if it is that you have brothers and sisters that are in grade 8 and 9, because whenever I do any grade 8 or 9 lessons, I'll do them on this platform, because I want to separate this from this one, okay, because this one is for grade 10, 11 also, and 12. All right, I'm just thinking of possibly having a platform for grade 12 alone, so that grade 10 and 11 is alone as well, and grade 8 and 9 is alone as well, so that people know when I'm on this platform, I'm dealing with this grade. When I'm on another platform, I'm dealing with another grade. Okay. Yeah. Okay. Anyways, let's hop on to this. We actually, the last time I was with the grade 10s, we actually looked at these problems here that you see here, and we went through them step by step. So I had actually given you this for homework. I had left this for you guys to do on your own. So we are going to go over these problems, the ones that I actually gave you, and then we're going to see if we can actually go ahead and do a bit of factorization as well. Hopefully we get there, but today we'll look at products, the simplification of products, and if possible we'll get into factorization. It just depends on how fast the lesson actually is. So let's take it one step at a time and attempt this. So remember, always when we look at an expression, we always ask how many terms are in the expression. So here, guys, in this expression that we have here, how many terms do we have? How many terms do we say we have in this expression? Thank you, Letobuhle. We have one term in the expression. Then 2. What is the relationship that exists with the one term? So we have a bracket and we have another bracket. So what does that mean? It means we're going to distribute. Okay, because the relationship is one of multiplication. Brackets mean multiply. So 2 is going to be multiplied with 3x. Then after that, 2 is going to be multiplied with 4. So you are distributing the 2x to the 2 terms inside the bracket. And when you do so, you apply S, N, L. Remember, guys, S means we multiply the sign. N means we multiply the numbers, and then L means we multiply the letters. And when we multiply letters, we think of law number 1 of exponents. All right, so that's very important. So if we look at 2x times 3x, we multiply the sign. A positive times a positive will give me a positive sign, of course. Then number 2 times 3, that is 6. Then x times x. Like I said, we apply law number 1 when we are multiplying letters. So when we are multiplying same bases, we keep the base, we add the exponent. So that will give us x to the power what? X to the power 2, my beloved grade 10s. Okay, so hopefully you understand that we get a 6x squared as our first term. Then we do the same thing. Take 2x, we multiply it by 4. When we multiply, we apply multiplication of sign, number, and letter. So positive times a positive is a positive. 2 times 4 is 8. Then the x gets combined with the 8. Okay, so that is us distributing the first term to the first term and the first term in our bracket to the last term in the other bracket. Then we do the same with negative 5. We distribute negative 5 to 3x. Then we distribute negative 5 to positive 4. When we do so, we apply the multiplication of our sign, the multiplication of our number, and the multiplication of the letter of the alphabet. So when we do so, negative times a positive is negative. 5 times 3, which is the number, is 15. The x combined. Then lastly, negative 5 times positive 4, negative times a positive is a negative. 5 times 4 is 20. Then we look at our terms. By applying the distributive law using the sign, the number, the letter, we have removed the brackets. We now have how many terms in the expression? 4 terms. But we can see that the inner terms, the middle terms, are like terms. And we know that the rule says we can add and subtract what? Like terms. So 8x minus 15x, when we add or subtract like terms, we keep the variable, which is x, because it is the same jersey for the same soccer team. We keep the variable as it is. Then we add and subtract the coefficients. What is 8 minus 15? That gives us a negative 7. So we have a negative 7x as our middle term, minus 20. How many terms do we now have in the expression? We have 3 terms. Can we add and subtract any of the terms in this expression? I'm going to pause and wait for you to answer me. Can we add and subtract any of the terms in this expression? Letokuhle says no. Queen says no. And I'm hoping everybody knows that it is a definite no. Why? Because x squared and x are unlike terms, and they are also an unlike term to 20. So therefore, these are unlike terms. We leave the expression as it is, and that's our final answer. This is simplified. Okay, move on to the next problem. 3x minus 2y, the whole thing squared. 3x minus 2y, the whole thing squared. When approaching a problem of this nature, do we know what we need to do? Of course. Yes, Liam, I do grade 12. Every single day in the evening, I'm doing grade 12, and I've been doing grade 12. So you can join me at 9 p.m. tonight. I'll be starting a new topic, functions. All right, and it will only be for an hour and a half. Yes, Amelia, I do grade 9. Grade 9 is done in my other platform, as I was explaining earlier on. I have another platform which is for grade 8 and 9 only. So the grade 8 and 9 only platform is my other TikTok page that is also called Maths is a Game, but the profile picture is having a green background. Okay, profile picture is green. Okay, here is this. Let me just give me a sec there. Profile picture is green, this one. So you come here, this one, please come here. This is the platform. When I go live, you will know by seeing the red thing around this one. This platform is the one for grade 8 and 9. Okay, so everything grade 8 and 9 is done on this platform. The one that I'm currently on is the grade 10, 11 and 12 platform. All right, and unfortunately I can't tell you times as of yet because I don't have a working fixed schedule. But for grade 12, so far we are doing things in the evening at 9. So okay, 3x minus y, 2y, the whole thing squared. What we do here, as the little Gutle said, we are going to open two brackets of 3x minus 2y. Okay, so there we have them, they are opened. Two brackets of 3x minus 2y. Okay, then of course we are going to apply the distributive law using S and L. First terms, we first multiply the first terms, 3x times 3x. Then we multiply the outer terms, 3x times negative 2y. So we're basically distributing 3x to 3x and then 3x to minus 2y. When we do that, we make sure that we are considering the multiplication of the sign, the number, then the letter. Okay, so positive times a positive is going to be positive. 3 times 3 is going to be 9. X times x. When we're multiplying same bases, keep the base, we add the exponents, 9x squared. Do the same thing with the distribution of that term to this one. Positive times a negative, negative. 3 times 2, 6. X times y, we combine the x and the y. Then we look at the inner terms. Negative 2y we distribute to 3x. Negative times a positive is a negative. 2 times 3 is 6. Y times x, we can write it as xy. Beautiful tender cutie in the comment section. Then we distribute the last term to the last term. The last terms in the bracket, negative 2y times negative 2y. Negative times a negative is a positive. 2 times 2 is 4. Y times y is y squared. So what if I correct the like term? Then I simplify. I'm kind of lost there. Karib, pian preso. What if I correct like term, then I simplify? Correct. What does correct mean? Don't know if you're trying to say collect. Okay, then in the middle, guys, we have like terms. Yes. Okay, so you are going to then add or subtract the like terms, negative 6xy minus 6xy. Remember, the variable xy stays the same. Then you subtract the like terms, negative 6 minus 6. Okay, so it's very important. Negative 6 minus 6, that is negative 12. Okay, please guys, make sure that you even check, verify with your calculator, because sometimes it's funny how learners will think that maybe negative 6 minus 6 is 0. All right, please, and when you punch it in your calculator, it's negative 6 minus 6. okay, which is negative 12. Okay, it's very sad when learners get things wrong because they can't add integers or subtract integers. It's a real big problem. XY is like the same uniform for the same kids in the same school. So the uniform stays the same, XY stays the same. We add and subtract the coefficients. Okay, plus 4y squared. Can we continue here any further, or do we end here? Are there any like terms? Okay, Letokohle definitely no. Right. Okay, moving right along. Next problem. Guys, you get the drill. I'm going to allow you guys in the comment section to basically tell me what the result will be here. So I'm going to give you 2 minutes because I think 2 minutes is enough for you to do this problem. And let's see what variety of answers you guys can get me, or if you guys get the concept. So give you guys, actually let me give you a minute to do this, 60 seconds. Let me time you. Grab my stopwatch here. And let's time you as well. So you're doing this problem, guys. Okay, we'll give you a minute, so 60 seconds. Queen, thank you so much. I see your response. Let's see if really and truly that is the case. And it resonates with everybody else's response. Okay, LV, I see your answer as well. Tender Cutie, I see you too. Okay. Yeah. So that is a minute. All right. So, guys, we need to also be cognizant of time when we do problems. You know, this is a problem that you should be able to easily do as a grade 10 pure maths learner, because in grade 9 you did problems like this. So it's like you are revising what you did in grade 9. So it should flow very nicely. So first term, because obviously how many terms do we have in the expression? We have one term. Then what relationship exists between the brackets? It's multiply. So what does multiply mean? We distribute terms using S and L. So 5x times 5x, guys, sign is positive, number is 25, letter is x squared. 5x times positive 3x, sign positive times a positive, positive. 5 times 3, 15. X times y, we combine the letters xy. Inner terms, negative times a positive, negative. 3 times 5, the number 15. Y times x, multiplication is commutative, so the order of the letters for multiplication, whether you write yx or xy, xy and yx are the same thing. Then lastly, negative 3 times positive 3. Negative times a positive, negative. 3 times 3, 9. Y times y, you add the exponents, it's y squared. Okay. Then lastly, what you finish finally and you do is you actually write down 25x squared. Okay. And then if you add the like terms, guys, the addition of the like terms gives you 0. Okay, minus 9y squared. Okay, and so those that basically said that the answer is 25x squared minus 9y squared, you guys were 100% spot on. Definitely 100% spot on. Moving right along to the next question. Okay. Okay, if you look at the expression, we ask ourselves the famous question, how many terms are in the expression? How many what? Terms are in the what? The expression. We start there, guys, when we're answering questions. Always, if they are asking you to simplify an expression, always ask how many terms are in the expression. Okay, so if you guys can tell me how many terms do you see? Very good, we have how many terms? 3, right? Remember, minus and plus will separate the terms. Divide, multiply, brackets, combine terms. So 5x here is 1 term. We count 1. The minus sign separates 2 because this is a bracket and it's combined, this entire thing. So 2. The minus sign separates 3. Are we together? So we have 3 terms. Next question. What operations do we see in the expression? So 5x is alone. Okay. Minus. So this 4x plus y squared means we open 2 brackets. 4x plus y into another 4x plus y minus 2 into 3x plus y into x minus 2y. So according to BODMAS, because remember, whenever we have an expression and we have many operations, we need to first start with the brackets. Okay, brackets. So 5x for now is going to chill. The negative is going to chill outside and wait. I am going to take care of the multiplication of these 2 brackets by applying FOIL. And for now, I'm going to have a big bracket to accommodate the resulting terms that come about from the multiplication of these 2 brackets. Okay. because this minus sign is also ready after we are done to be distributed inside the bracket that will be the result from the terms that I will get from my multiplication and distribution of these two brackets. So let us FOIL. S and L, positive 4 times positive 4 is 16. X times X is X squared. Then we distribute the next one. Positive 4xy. We distribute y into 4x. We get another positive 4xy. We distribute the y into the other y. We get positive y squared. So these are the terms inside this bracket for the multiplication of these two brackets. Okay, guys, hopefully we are all on board with what has happened here. This is our application of FOIL. Okay, then let's move on. We have a negative 2. So for now, negative 2 is going to chill outside, and I'm going to distribute using FOIL for these two brackets here. Negative 2 for now can chill outside and wait for the outcome. All right. Okay, I'm really sorry. See now, this is gonna be in the way. Anyways, 3x times x is going to give us positive times a positive. Positive 3 times 1 is 3. X times x, x squared. 3x times negative 2y. Positive times a negative is a negative. 3 times 2 is 6. xy combined. Y times x. Positive times a positive is a positive, and then we have positive xy. And lastly, all right, let me just close that bracket there. Y times a negative 2y. A positive times a negative is a negative. 1 times 2, there's a coefficient of 1. 1 times 2 is 2y squared, because y times y is y squared. We keep the base, we add the two exponents. There's a 1 there that you don't see, and a 1 there, so that we add those, you get y squared. Right? So far, it seems like we are good. The like terms inside the bracket. Okay, obviously I wouldn't waste my time. You know, I think this 4xy plus 4xy, I would probably write 16x squared plus 8xy immediately. All right, this is just me lengthening it out so that you guys can properly see the steps that I've done. So the 4xy plus 4xy, these are like terms. I get 8xy. The negative 6xy plus 6xy gives me negative 5xy, because the same jersey xy, we add the coefficients. Negative 6 plus there's a 1 here that you can't see, which is giving me negative 5xy minus 2y squared. Now guys, we can finally distribute the negative sign for all the terms in this bracket. All right, this negative, there's a 1 there that you don't see, which is invisible. This negative 2 as well, we distribute inside the 3 terms. We always do this, guys. The negative 1 needs to be distributed to all 3 terms, not just to the negatives, not to the 16x squared alone, but to all 3 terms. What does that distribution help us with? It removes the bracket. Okay, so now we are going to have 5x was waiting patiently outside, all right, as a term on its own. Negative times 16x squared, negative 16x squared. Negative times a positive there, negative 8xy. Negative 1 times positive y squared, negative y squared. Then we come here, we distribute the negative 2 to all 3 terms here. negative 2 times positive 3x squared, negative 6x squared, negative 2 times negative 5xy, positive 10xy. And a negative 2 times a negative 2y squared is a positive 4y squared. Now our expression, guys, is really having 1, 2, 3, 4, 5, 6, 7 terms, which we can now go ahead and look for what? Like terms. We've taken care of the brackets. The exponent for this bracket, we actually opened the two brackets, so we applied the exponent correctly. There was no division. Multiplication, well, the negative 1 had to be multiplied to the bracket. We distributed it correctly. Now we are left with addition and subtraction. But in that addition and subtraction, we can only add and subtract what? Like terms. So now we need to check where are our like terms. Negative 16x squared is a like term with negative 6x squared. So the negative 16x squared minus the 6x squared should give us a negative 22x squared. These two are like terms. So what you do is you say negative 16x squared minus 6x squared. So we keep the variable x squared and we subtract the coefficients. Minus 16 minus 6 is negative 22. Okay, next like term. Negative 8xy is a like term with positive 10xy. That's why I'm putting them both in circles. When we are adding those like terms, we keep the uniform xy. Then we add and subtract the coefficients. Negative 8 plus 10 will give us a positive 2. Negative 8 plus 10 gives us a positive 2. Right? Then we have a 5x there, which is alone. It is lonely. So we are just going to punch it in there in the mix. It's alone, it's lonely, it has no like term, so we write it plus 5x because it's a positive 5x. Then negative y squared, okay, is the same thing as positive 4y squared. It's like terms, this one. So what do? We keep the variable y squared as it is. We add the coefficients. There's a negative 1 that we don't see, a 1 that's there. What's negative 1 plus 4? Your calculator should help you if you don't know off by heart. Negative 1 plus 4 is positive 3. So therefore, we have a positive 3y squared. So this here, guys, is our final answer, and it agrees with Queen's answer that she got in the comment section, and which I think it was the Leto Kuhle as well and Tender Cutie that got the same answer as well. Right, well done, good job. So our thinking process, guys, when we do these things is that we must always first observe the expression. Then we must ask, how many terms do we have in the expression? When we have established how many terms we have in the expression, for instance here we counted, there is 1, 2, 3, then we apply BODMAS and work in the order, the strict order of BODMAS. We start with the brackets. So 5x needs to wait for now, minus needs to wait for now. We deal with the bracket. 4x plus y here dealt with correctly. We open two brackets of 4x plus y. Then we FOIL. that is applying or dealing with the bracket. Minus, we deal with the bracket, foil the bracket. We get the expression, we make sure it's in brackets, and we ensure that we add the like terms inside the bracket so that we have a concise, simplified bracket. And if there's a negative sign, guys, please do not make the mistake of not distributing the negative sign inside all of the terms, because most learners, that's where they go wrong. They do not distribute the negative side for all the terms, the negative 2 for all the terms. And then that's where silly mistakes get made. Then we add and subtract like terms, we get our answer. It's as simple as that. No complication. All right. Any questions in the comment section? Okay. Anyone who wants to support me, the live creator there, by double tapping nicely so that we get our likes up there. I'm also not against gifts, guys. If you want to support my live goal, that would be great as well. It helps a lot, goes a long way. So please don't be scared of doing these things if it is within your power or capacity to do so. All right. There's those 2026 gift, live gift there that you guys 2026, since we are entering 2026 in a few hours, all across the world there are other countries that are already celebrating 2026 because of the time zone that they live in. We will celebrate entering into a new year, and some countries will still be waiting to celebrate entering into the new year. All right, so yeah. Okay, the next question here that we have is 2x minus 5. 2 terms inside this bracket into 4x squared plus 10x plus 25, 3 terms inside the bracket. But in the expression, how many terms do we have in the expression? How many terms do we have in this particular expression? Do we see? How many terms we have in the expression? Do we see it, guys? How many terms do we have in the entire expression? We say, how many terms are in this actual problem? Thank you, Leto Kuhle. 1, guys. Remember, this is 1 term. We said most that brackets do what? Brackets combine terms. So this bracket and this bracket make it such that we have 1 term. Bracket makes it 1. This bracket makes it also 1. But then because the relationship that exists between brackets is one of multiplication, it's like you are combining these 2 brackets to make it 1 term. So we say there is 1 term we say there's 1 term in this expression. But if I was to say, if you look at this bracket, inside this bracket, how many terms do you see inside this bracket? Inside this bracket, there are how many terms inside? Yes, Mushi, there are 2 terms inside the bracket here. And then if I was to ask you how many terms are inside this bracket, how many terms are inside this one? There are 3, exactly. There are 3 terms inside this bracket. You guys get the point. But when I ask you how many terms in the entire expression, then you have to say there's 1. What makes it so that it's 1? It's because, remember, brackets make it 1 term. This bracket makes it another term. But because the relationship that exists between these 2 brackets is multiply, this becomes 1 because multiply combines. Okay, so let's come now and look at how do we deal with this particular problem. We've already established there's only 1 term. What combines is multiply. So what do? We distribute. 2x is going to be distributed to the first term, 2x is going to be distributed to the second term, 2x is going to be distributed to the last term. However many terms are inside this bracket, we take the 2x, we distribute it to those terms. Then what are we going to do? Apply SNL. We multiply the sign. When we multiply a term, we multiply the number, we multiply the letter. Okay, for these three terms. After we are done, we take the -5 king DRC. We do the same thing. -5 is distributed to 4x, -5 is distributed to positive 10x, and -5 is distributed to 25. That is how we simplify this given expression. Anyone who is lost as to what I am saying to you guys? Okay. And when you do each one, you are saying the multiplication of the sign gives you what? The multiplication of the number gives you what? The multiplication of the letter gives you what? Because SNL means we multiply the sign, we multiply the number, we multiply the letter. So let's go. 2x times 4x squared. Let's start there. What do I get, guys? Let's see in the comment section if you guys know what's 2x times 4x squared. In the comment section. Moshi says 8x to the power 3. So is Tender QT saying the same? Right. So I hope we agree. Positive times a positive is positive. 2 times 4, the number is 8. X times x squared. Remember guys, x times x squared. This x has an exponent 1. So when we are multiplying same bases, we keep the base, we add the exponent, we get x to the power 3. So that's why we say the answer there is 8x to the power 3. Right? 2x, we distribute now to 10x. Positive times a positive, positive. 2 times 10, 20. X times x, x squared. Very good. Ethical hack. Do the same thing. 2x times positive 25. Positive times a positive, positive. 2 times 5, 25, 50. The x gets combined with the coefficient, which is 50. Very good, Malotana. Plated that. You guys get it 100%. Very good, Letokuhle. You went the extra mile. Now we are done with distributing 2x. Now it's time for -5 to get the taste of being distributed to all three terms. Now, -5 times positive 4x squared. Sign, number, letter. Negative times a positive, negative. 5 times 4, 20. X squared gets combined to the coefficient. Okay? Do the same thing to the next term. Negative times a positive, negative. 5 times 10, 50. The x snatched next door, combined. Then lastly, negative times that positive, negative. 5 times 25, 125. Now we have those terms. We are done with the distribution, DL, distributive law, using SNL. We are done with the distributive law using SNL. Okay. How many terms do we have? 1, 2, 3, 4, 5, 6 terms. Now, what is the next step that we need to take? We have addition and subtraction. Brackets are done. No exponents. Division, no. Multiplication, we multiplied. Addition, now we have addition and subtraction of terms. but we know that we can only add and subtract like terms. So which ones are our like terms? Okay, 8x cubed is obviously unlike any other. Plus 20x squared is the like term to negative 20x squared. So in your head, you are going to be like, plus 20 minus 20. That, what will that give you? Plus 20x squared minus 20x squared. That gives you 0. So we have nothing. Okay, we have nothing. 50x is a like term to negative 50x. Okay. Okay, are we together? So what is 50x minus 50x? What is plus 50x is the like term to minus 50x. Why? Because they both have x, with the exponent both being 1 for both x's. So what's 50x minus 50x? That also gives us another 0. So we have nothing. All right, guys, 20x squared was the like term to this negative 20x squared. When we add these two, we get 0. 50x minus 50x, when we add these two as like terms, they also give us another 0. Negative 125 seems to be the only one that is left. So we are now going to go ahead and write negative 125, which is our final expression. 8x cubed minus 125. That is that. Okay, that is that. Okay. Are we good? Any questions, guys? Any questions at all? Okay, so that is the expression, that is the result, okay, after our distribution. Okay, so guys, this here we call multiplying a binomial with a trinomial. In other words, 2 terms multiplied by 3 terms. We simply use the distributive law, guys. There's nothing complicated about it. You are simply taking the first term, you distribute it by multiplication to all 3 terms. You get finished and done. You then take the next term in the bracket, you distribute it to the 3 terms inside the bracket. Finished and done. Then after that, you add and subtract like terms. Does that make sense? So that's how you are able to take care of the simplification. Okay. Yeah, well, 6813002440783. Follow the live creator. Follow the live creator, and definitely I will be here helping out. You can also DM me if you want, I could say, support in your journey in grade 11 in the coming year. Okay, I've had grade 11 learners that have basically been part of my, you could say, group that I've been able to help and support. Of course, smaller nyana fee there, but all in all, yeah, I know for a fact that, for instance, some of my grade 11s have let me know that, you know, some of them don't have a teacher at school, but I can promise you, I can tell you this, that some of them I've been able to support in the sense that they've been able to become a benefit and a help in their own schools, because they are ahead of the syllabus with me, and then it helps them a lot when it comes to their schools, so that they can help other learners, but also simultaneously help themselves. Okay, and grade 11 is a critical grade because application for grade 12 in 2027 will be dependent on your results at the end of the year. Okay guys, I think you can do this one on your own. Okay, my goodness, Pakistan, what is this? Right, not in my life, my friend. That's just something I would definitely never encourage. Yeah, and not because I'm saying that you guys and I can say I discourage that. What if something just terrible happens with that, you know? So yeah, also it's so irresponsible. Young people, no, we need to do better. We need to make better choices, really. Yeah, and I'm not saying it because I'm trying to be holier than thou here, but yeah, drinking I don't encourage because I don't drink, and I don't, yeah, in that sense. Anyways, please do this one, guys. You've seen me do this one. Now I think it's an opportunity now to check if whether you are able to do this one on your own. So what I'm going to do is I'm actually going to time you. I'm going to give you 3 minutes. Okay, yeah, to do this one. I think that's enough time. Actually, not 2 minutes. 2 minutes? Yeah. I'm gonna do a challenge with you. Brother, you're good at teaching, so I think I'm gonna do a challenge with you. Your boy Kim. Your boy Kim. Can we please follow each other or go live soon for a challenge? We can talk 681300. Just DM me. I'll give you the flyer so that you have it after I'm done with the lesson. Okay, a few seconds, guys. You got less than 30 seconds now. You should be approaching completing the problem. If you haven't already, Tender Cutie, I see you are done. Unjabs is done. Mushi is done as well. Yeah, we're looking at this specific problem, guys. Okay, that specific problem. Simplify that one. Okay, Queen is also done. Okay, stop right there. 3 minutes is 3 minutes. It can't be more than that. So guys, here I see x cubed plus 27. So I'm not going to really be running through step by step, but x times x squared we know this is what's going to be happening. So the first 3 terms, x cubed minus 3x squared plus 9x Those are the first three terms. X times x squared, x cubed. X times minus 3x, negative 3x squared. X times 9, 9x. Then we take positive 3 and distribute in the three terms. 3 times x squared plus 3x squared. 3 times negative 3x, negative 9x. 3 times positive 9 plus 27. Guys, the beauty is the more of these that you do, you get your mind into second gear level, where your mind doesn't really think about the multiplication, but it automatically sort of like, as long as you are doing things accurately, consistently, through practice, you get to a place where you no longer really think too deeply about what you are doing, but it automatically comes, you know. Yeah. So please make sure. Then like terms, x cubed is obviously on its own. Okay, 3x squared, that's negative, and plus 3x squared, these two are like terms. So what is negative 3x squared plus 3x squared? Okay, that will give you 0. 9x and minus 9x, those are like terms. Those two, when you add them, that will give you another 0. And then lastly, plus 27 is the only remaining term. So the final answer is x cubed plus 27. X cubed plus 27. That is the final expression that we get for this particular problem. Let's move right along, guys. Here's another one. Now this is a meal and a half. Okay, this is a meal and a half. Brackets x cubed minus 1. The second bracket 2x plus 1. The last bracket 4x squared minus 2x plus 1. So we ask the normal question, and that is, how many terms are in the expression? How many terms are in this expression? 1. Thank you so much, guys. You now Mushi, getting into the swing of things, eh? Yeah, counting the number of terms is not something very difficult. Once we understand who is the combiner in maths and who is the separator, you know, the combiner, the one who brings people together, the one who marries, the one who joins people together, you know, the unifier, multiply, divide, those are the things that combine. Brackets, those combine. Right? Addition and subtraction, on the other hand, they are the separators, addition and subtraction. So these brackets combine, right? This first bracket combines x cubed and minus 1 to become 1. This bracket combines 2x and plus 1 to become 1. This bracket here combines these three terms to become 1. But what combines everything is the fact that brackets in maths, okay, when you are talking about this with that, the relationship between these two, brackets actually mean multiply in maths. So it's like you are multiplying here and you are multiplying there, which then further combines everything to become one term. So that's why we say it's one term, guys. It's very important, this thing. After that, we check out Mr. Who? Mr. BODMAS. Brackets. Well, we have 1, 2, 3 brackets. Is there anything we can do inside the brackets insofar as simplifying each bracket? Well, it seems like no. E, do we have exponents? Well, we have exponents for single terms, but they don't help with anything. Division, nothing there. Multiplication, well, there it is. This means multiply. All right. So just like 3 times 2 times 1 can be found by saying 3 times 2 is 6, and then taking 6, multiplying it with the remaining 1, you get an answer of 6. We can do the same thing in this situation. We are multiplying 1, this, and that. All right. So you can see these first 2 brackets are both what? Binomials. So if you want to, you can multiply these first 2 using FOIL, keep the bracket, and then after getting your 3 terms for these 2, you take those 3 terms, you will multiply them for those 3 as well. That's one way of doing the problem. Or you could decide to keep the 8 to the power 3, 8x to the power 3 minus 1. Keep it, multiply these 2 together, all right, and get the prevailing answer from the multiplication of these 2. After you are done, you are going to have a bracket for these 2, and then you can basically multiply it with this first bracket that you kept. So either way, guys, doesn't matter. At the end of the day, you will get the same answer. So what I'm going to do, I'm going to do this problem in 2 ways so that you can see how both ways actually work, whether you are doing one or the other. So let's start with this one, where we are going to choose to keep 8x to the power 3 minus 1. Just like if you wanted to, if you're multiplying 3 times 2 times 1, you could choose to keep 3 and then multiply the last 2. What's 2 times 1? It is 2. Then what's 3 times 2? It still gives you 6. So this is the same thing I'm doing here. I'm keeping 8x to the power 3 minus 1, and I'm choosing to multiply the last 2. So that means I'm going to play the distributive law game with the second bracket and the third bracket, whilst keeping this one as it is for now. Okay, I hope you guys get me. Just like 3 times 2 times 1, you can find 3 times 2 times 1 either by keeping 3, multiplying the last 2, and then you multiply 3 times 2 to get 6, or you can multiply the first 2 and get 6, keep the last one, and then still get an answer of 6. So this is just what I'm doing here. I'm choosing to keep the first bracket and multiply the last 2. So let's do that. Now we are going to use the distributive law, DL, applying multiplication of sign, number, and letter. Willie Kalex, you are asking why. I just explained to you why. Because just like, why are you doing this? Let me just, I think when you are displaced, I think you are displaced. I have a feeling you are displaced. All right. Okay, let's come here then. 2x plus 1 into 4x squared minus 2x plus 1. So let's multiply 2x times 4x squared. That gives us, I see your answer there, Queen. 2x times 4x squared gives us positive 8x to the power 3. Then we distribute 2x times negative 2. Positive times a negative, key negative. 2 times 2, key 4. X times x, key x squared. Okay. Two x times a positive 1 there. 2x times positive 1. Positive times a positive is positive. 2 times 1 is 2. And then the x next door. Now we distribute 1 to all 3 terms. 1 times 4x squared plus 4x squared. 1 times negative 2x, negative 2x. 1 times 1, positive 1. Alright? Then we deal with the like terms in this bracket. So we still keep 8x to the power 3 minus 1 for now, and we deal with the like terms in the last bracket. So what do you see, guys, are your like terms in the last bracket? 8x cubed stays. Negative 4x squared plus 4x squared, that gives you 0. 2x minus 2x, that gives you 0. 1 plus 1, that is what's left. So here currently, guys, we have this that is left from the multiplication of the last 2 brackets. We have 8x cubed plus 1 for the second bracket. Now we are going to wrap up the show. You see, by multiplying the last 2, I got 8x cubed plus 1. Now I can deal with these 2 brackets. Does that make sense, guys? Just like if you have 3 times 2 times 1, you decide to multiply the last 2, you get 2. Whilst keeping 3, you deal now with 3 times 2, you get 6. Okay. Okay, I hope it makes sense, guys. I hope it makes perfect sense and you understand what's happening there. Okay. So now we are going to do what here? We are going to distribute 8x cubed to 8x cubed. So Queen, your answer seems like it's materializing. Positive times a positive is positive. That's the sign. Number 8 times 8, 64. X to the power 3 times x to the power 3, we keep the variable. We add the exponents. 64x to the power 6. We then take 8x to the power 3, we times it by 1, plus 8x to the power 3. And something multiplied by 1 gives us that particular thing, because 1 is an identity element, okay, for multiplication. Then we take negative 1, we multiply with 8x cubed. We distribute the negative 1 now. So it's negative 8x cubed. Thank you so much, Science Genie. The best in the game is Science Genie, guys. See the guy who's commenting there, the best New Year's gift? That's the guy who's the best in the game. Maths and science, that's the man. Then negative 1 times positive 1. Negative 1. Now you can see, guys, we have like terms there. Okay, those like terms, we add and subtract those like terms. So the final answer is 64x to the power 6. 8x cubed minus 8x cubed is 0. So we are left with negative 1. And that is basically our final answer. Do we see that, guys? Do we comprehend what we have just done? Does it make sense? Okay, right? So as I am repeating and I'm saying again, just like 3 times 2 times 1 can be done in 2 ways. Meaning this problem can be done by multiplying the first 2, getting the answer whilst keeping the last value. Then after you've gotten the multiplication of the first 2, you can take that first number and multiply with that number that you kept. Okay, does that make sense? Or you could decide to keep 3, multiply the last 2, just like we've done here. We kept 8x to the power 3 minus 1. We decided to multiply the last 2. Then we got the expression for the last 2, which is 8x cubed plus 1. Now we go back to multiplying it with what we had kept, and we get the final answer. Okay, yeah, guys, this is simplifying. So simplifying means we expand, and when we expand, we multiply out, we then add and subtract like terms, and we get our answer in simplified form, which is 64x to the power 6 minus 1. All right, I hope that makes sense. That's one way of doing the problem, or we could have done it by, let me just show you that we could have done the same problem, just this time round, multiplying the first two and keeping the last bracket. So let's see if we will get the same answer if we keep the last bracket, not the first. So if we chose, or we had decided to multiply the first two and then keep the last, let's see what would have resulted. So that is two brackets. So we are going to multiply the first two. We get 16x to the power 4. 8x cubed times 2x gives us 16x to the power 4. Because a positive times a positive is a positive, 8 times 2 is 16x to the power 3 times x. We multiplying same basis, so what do we do to the exponents? We keep the variable x and we add 3, and there's that 1 that is there. We get 16x to the power 4. 8x cubed times 1. Positive times a positive is a positive. 1 times 8, x to the power 3. Then we take negative 1, we distribute to the same two terms. Negative 1 times 2x, negative 2x. Negative 1 times positive 1, negative 1. That is our first bracket, multiplied by the bracket we had kept, which is 4x squared minus 2x plus 1. Right. So far, are we okay? Do we see this first bracket? Do we have any like terms inside this first bracket? X to the power 4, x to the power 3, x, and negative 1. There's no like terms, guys. Absolutely no like terms at all. Now check what we do next, right? Now we are going to see there are 4 terms versus 3. So all we need to do here, guys, is take each term and distribute it to the terms in the last bracket. Okay, that's all we do. So what is 16 times 4? Well, it is 64. Then x times x, x to the power 6. 16 x to the power 4 times negative 2. What's 16 times negative 2? Negative what? Negative 32x to the power what? To the power 5. 16x to the power 4 times 1, that's plus 16x to the power 4. We're done with 16. We do the same thing with 8. Take 8x to the power 3, distribute it to the 3 terms. Positive times positive, positive. 8 times 4, 32. X to the power 3 times x squared. 3 plus 2 is 5. Do the same thing to 8x to the power 3 times negative 2. We get negative 16x to the power 4. We do the same thing to 8x cubed. We multiply it by 1. We get plus 8x cubed. Now we do the same thing. We take negative 2. We distribute it to the 3 terms. And we do the same thing with negative 1. We distribute it to the 3 terms. Let's take negative 2. We get negative times a positive is negative 8. negative 8. X times x squared is x to the power 3. We take negative 2, we multiply it by negative 2, we get positive 4x squared, because negative 2x times negative 2x is positive 4x squared. Negative times a negative is positive. 2 times 2 is 4. X times x is x squared. We take negative 2x, we multiply it by 1. We get negative 2x. Lastly, negative 1 needs to be distributed to all three terms. So negative times a positive will give us negative 4x squared. Negative 1 times negative 2x gives you positive 2x. And then last but not least, negative 1 times positive 1 is negative 1. Right. Now, obviously, for this situation, our expression is way longer. But do you know what, guys? This, to me, would show that you yourself can see that all we are doing here is we are applying the distributive law. All right. And when we do so, we make sure we multiply the sign for each term, the number for each term, and the letter for each term, so that we have the resulting terms, which we can then simplify. Now, guys, this now means we just need to check where our like terms are. So 64x to the power 6 is alone. There's no other term that has an x to the power 6. Negative 32x to the power 5, okay? He is a like term with who? With him. Do you see that? There's no other x to the power 5 that I can see here, so that is the only like terms that we have. Negative 32 plus 32, x to the power 5 will give you 0. So 0 is the result. So that means he's gone. We have no term that is going to be x to the power 5. Plus 16x to the power 4 is the same as negative 16x to the power 4. Is there another x to the power 4 term? No. Plus 16x to the power 4 minus 16x to the power 4 gives us another 0. So that means we have no term that has x to the power 4 in the expression. 8x to the power 3 minus 8x to the power 3. These are also like terms. This minus that is going to give us another 0. So that means we don't have any x cubed terms in the expression. X cubed terms, goodbye. Hey guys, do you see? It's like we've removed everything. Let's come here now. 4x squared is the same as negative 4x squared. These are x squared terms. This minus that gives you 0. Boom, gone. Then lastly, negative 2x plus 2x. These are like terms. Once again, 0, gone. We don't have any x terms. The only surviving member in this expression seems to be negative 1 and 64x to the power 6. So therefore, our final answer is going to be 64x to the power 6 minus 1. 64x to the power 6 minus 1. All right. That was a bit long, but at the end of the day, still gives us the what? The same answer. Right. Okay. Do we have any pressing questions that anyone has right now? Are we clear? Okay. Guys, I think I'm not going to drag this out. This is basically simply what I wanted to kind of wanted us to look at today. And I'm going to leave this problem. You can write it down. I'm going to leave it as your game challenge problem. Okay. leave this for you to do. Okay, and then I will encourage you to go to your textbooks and start looking at other problems that have to do with the product of terms, products, a monomial by a binomial, a monomial multiplied by a trinomial, a binomial multiplied by a trinomial, a binomial multiplied by a binomial, and other complex problems where you have many terms and you have to simplify using BODMAS, SNL, and applying the distributive law, right? The more of those that you can actually say you can do very well, that will help you out, in your algebra journey, so that you can ensure that you are doing what's right. The next time I have a live session with you, grade 10s, we'll be starting factorization. All right, we will start factorization the next time you and I meet in this live session, right, which will most likely be tomorrow, maybe very early in the morning. So yeah, thank you guys, it was great. I hope you guys had a great time, and let me just say to all of you, 12 hours away from saying Happy New Year, let me say Happy Early New Year. I hope 2026 will be the best year for you, that all your dreams, goals, objectives that you have for the upcoming year will be fulfilled in Jesus' name, that every academic goal that you have, academic aspirations that you have, and anything that you'd like to accomplish for the sake of your own personal education, which will lead to your own personal advancement in life, will be fulfilled, and that you will have joy whilst learning. All right, yeah, I love the fact that you guys are here. It means that you guys are looking at education beyond the four walls of a school. The governmental organization, which is the school organization, yes, will be officially opened. Some of you are opening very early, and some of you are opening on the 14th. But that does not mean we don't stop learning. Just because the institution is not opened does not mean we close our minds, right? True education showcases itself in wisdom. When people apply true knowledge, they become wise. So please, guys, let us be people that are invested in our own development, personal growth, and let us try and learn things above and beyond just what we learn inside the governmental institution, which is called school. School can limit you as well, guys. So if you want to expose yourself to more knowledge, do so. Read books, listen to educational podcasts, equip yourself, not only just in the subjects that you do at school, but just generally in things that have to do with life. Okay, you guys will soon be stepping out of school and stepping into the real world. So it becomes important for you to know what ways can you actually navigate life in a wise manner. So please, guys, be invested in your own development and know things that will help you grow and become a better individual. Feed your mind with good, substantial things, things that will really help develop you. There's a lot of knowledge, guys, that is knowledge that if we can get access to, will lead to our own growth and prosperity. And I think too many people close themselves off from that knowledge because they look at school as the only avenue through which they can learn. Once schools are closed, people become closed-minded, and they also become people that do not really apply knowledge for the benefit and welfare of themselves. And then they live lives that are very destructive, which is not an indication to me that you are someone who is a true learner in life. Okay. Okay, so thank you so much, guys. I hope you guys enjoyed the live lesson, that you benefited from it. We'll see you again next time, and thank you. Have a great day and a great happy new year in 2026. Bye, Mushi. Bye, bye.